Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 8 for your course. My name is Engineer Jaffar Ali and I'm instructor for this course. So today's our first part. This video is the first part of the 8th lecture, and in this lecture we are going to discuss about two protocols. You know that in the previous classes we have started our routing protocols, and in continuation to that we will continue and study further protocols that are used for routing. There are two more protocols that are used in interior routing, interior gateway routing. The first one is IGRP, that is Interior Gateway Routing Protocol, and the second one is EIGRP, that is Enhanced Interior Gateway Routing Protocol. So let's get started. This is our agenda for today. Today we will be discussing IGRP, EIGRP tables. How do you configure EIGRP and how do you verify EIGRP? So this is the agenda for the first part. So what's IGRP? IGRP is basically a Cisco proprietary. It means that these are only applicable for the routers that are of the vendor Cisco. No other router are using these kind of protocols. It is a very good protocol actually, but it is owned by a Cisco company. You know that Cisco is a vendor that manufactures routers actually. So this protocol is proprietary to them, and it is basically a distance vector routing protocol. And this means that if you want to use this IGRP in your network, you should have all the routers to be belonged to Cisco, actually the family of the Cisco routers. Moreover, IGRP has a maximum hop count of 255, with being default of 100. You know that in RIP, that was routing in information protocol, there was 15, and the limit was 16 actually, and the default value was 15. But now you can see here is the default value of 100 actually, and it is the same as we will be using in EIGRP. And IGRP is basically also uses a different metric than other protocols. Let's suppose IRP or OSPF वगैरह. It basically uses bandwidth and delay of the line, and moreover it can also include load as well. So it is not limited to just these two metrics. Let me show you this bandwidth and delay. You can also include load and further things in basically EIGRP. So IGRP is limited to bandwidth and delay, plus you can add something more, and this is called a composite metric because you can add reliability, you can add load, and maximum transmission unit as well can also be used. So they are not used by default. You can have not activated this by default. You have to activate them, and you have to indulge them as well if you want to use them as a metric. So this is a common difference between you've already learned about this IRIP, routing information protocol. So it will be best to learn IGRP as comparison to this RIP. So you know that RIP was were best considered best for smaller networks, while as this IGRP can be used in larger internet works. So this is a major difference, and RIP does not use any AS basically numbers. They were using the systems AS, but they were not using the numbers of them. So this is a different because you have to use the number for activation in IGRP. Similarly, IGRP gives a complete route table updated every 90 seconds. The updated time is 90 seconds, whereas in the other protocol it was 30 seconds. Similarly, the administrative distance, or you can say, excuse me, the administrative distance was considered to be 100, in IGRP, whereas it was 120 in the RIP protocol. The bandwidth actually in this IGRP uses the bandwidth and delay as a line of metric, and you can have more of things that you can add up that we have discussed in the previous slide, and the maximum number of count can be of 255, but the default value is 100. Similarly, you can have a difference of you can see that the hop count as well and the metric as well, because this protocol uses excuse me, a hop count as a metric, just a hop count, nothing else. So let's talk about this advanced version of this IGRP. IGRP was basically a distance vector routing protocol. It was mentioned in the earlier slides, but this EIGRP is a kind of modified version of EIGRP, IGRP actually. So you know that that was the distance vector routing, but it is commonly termed into the hybrid routing, or you can also call it advanced distance vector routing. And the reason is because it has combined the good versions of both of these distance vector as well as link state routers. So you know that there was two kind of routings. The first one was a distance vector routing, and the second one was link state routing. And there is a third kind in which this EIGRP lies, that is basically hybrid. So this is the hybrid routing, and in this under this further category, this EIGRP lies. So IGRP lies over here, distance vector routing, and EIGRP basically lies in the hybrid because it combines the good phenomena of distance vector as well as this link state routing. So similar to the IGRP, it is actually the propriety of a Cisco vendor. The vendor that is Cisco. So it means that all the routers belong to the family of Cisco will be using it. No other protocols or routers will be using this kind of protocol, and it is a very cool protocol that is used by Cisco. And you know that why we are discussing this protocol, because of the Cisco, because Cisco captures a lot of market share when it comes to routing. So that is why we are going to learn about these protocols. And the more thing that you should know about this is there are a number of powerful features that make EIGRP a real standout from IGRP and other protocols. And the main ones are that it supports the IP, IPX, any latest version, and Apple talk why protocol dependent modules. These are something that you will be listing in the, this is not relevant to the course, but it is not something that you cannot expect from the field life actually. So that is why I have mentioned it over here. So it provides very much efficient neighbor discovery, and we will discuss that how it provides efficient neighbor discovery in the coming slides as well. And the communication, why basically this is a kind of protocol that this EIGRP use. This is a kind of protocol that is used for the transport layer actually. So this is RTP protocol, that is reliable transport protocol. And the best service or the best selection, why this is an algorithm that is dual, that you will actually diffuse this stands for diffusing update algorithm. So this is also an algorithm that is used for the best path selection. So let's go forward. What is EIGRP? So you can see that EIGRP is a combination of all these different things that are that IGRP supports, and as well as link state routing. So enhanced IGRP supports rapid conversions. In the last class in which we discussed about RAP and OSPF, you learned that there was a limitation or bottleneck, that was slow convergence. So it provides a very fast convergence, and it can also reduce the bandwidth usage actually. So you have a maximum efficiency for the bandwidth utilization, you can say. So it also provides that kind of service, and it also provides multiple layer network layer support. And how does this provide? Because of the use of this diffuse update algorithm, and this basically is to select the loop free routes and enable fast convergence. For example, if you have a route from A to B, so it will be able to find another path very quickly as compared to another protocol because of its rapid convergence. So that is basically the thing, and it can supports up to 6 unequal paths for a remote network, and the value is set it by 4 as default. So the value of unequal paths is basically 4 if you want to have a remote access. So you will be having 4, the value 4 actually by default, and you can make it up to 6. So let's compare this EIGRP and IGRP. So these both use basically the similar matrix, that is basically the bandwidth, the load, the hop count, any other thing that you want to indulge in. The major thing is basically the delay as well. The major two matrices are, let me write it down for you. The major two matrices are basically the bandwidth and the delay, and you can have any other matrix if you want to indulge that into this as well. And it will also provide the same load balancing. It will also provide the same improved convergence time. It will also help you to reduce the load or network overhead that is basically used by the control messages. And the number of hop count is basically 255, the maximum number of hop count, but the value is set to be 100 by default. And this EIGRP can differentiate between internal and external routers as well. So EIGRP is basically a classless, can also support this classless and VLSM. We have discussed about these as well in the previous classes, so I think you will not be having any trouble in that. And it is, I've told you, that is a advanced or enhanced distance vector protocol. Instead of routing, you can also use this term, enhanced distance vector protocol. Like IGRP, EIGRP also uses the concept of the autonomous system, but the only difference is that as compared to the RIP protocol, that was a routing information protocol, it uses the number actually of the route AS system. And unlike IGRP, this EIGRP includes the subnet mask into its route updates. So it will, the only difference, or you can say the only difference between this IGRP with this EIGRP is basically that it includes the subnet mask. That is a very important information as well into the routes update, that is the routing table actually. So this is basically the thing. And this dual update algorithm is that if your one path is you haven't heard about any path, let's say for 90 seconds, so this thing will automatically, this router will automatically, if it's transmitted a packet and it haven't received any information about the requested packet in 90 seconds, it will automatically discard and replace this path with another path. So this is a very cool kind of protocol. And this also supports the IP protocol. You know that IP is very much essential. So it's this EIGRP also supports this IP protocol, and it can provide no updates actually. And the root updates can only be sent via this using this this IP address, that is 224.0.0.10. This is the IP address for which this IGRP is using to transmit the route updates actually. So the route updates are multicasted by using this kind of IP. So whenever you see this kind of IP, you make sure that you are using, you have to know that you are using basically EIGRP. So hello messages are sent to the neighbors every 5 seconds. So 60 seconds mostly in the vans. And these are the most thing that you are going to look at or look over it. So EIGRP doesn't send any link state packets such as OSPF. uh, so instead of traditional distance vector routing updates containing information about the network plus the cost of the reaching them, the advertising router, and EIGRP has the link state characteristic as well. So it synchronizes the routing tables as I've told you between the neighbors at a startup and then sends specific updates only when the topology change occur. So you can see that we have combined the effectiveness of distance vector routing as well as the link state routing. So that is why this is known as advanced or enhanced version of IGRP, or you can say distance vector routing, but the common name that you can find in the books is basically the hybrid routing protocol. So hybrid routing protocols include this EIGRP protocol. So the terminology that you will be seeing in the field inshallah is basically, you can see over here that the neighbor table IP, the next hop router, and the interface through which you can connect to the next hop. So this is basically a kind of routing table, and the topology, it can, this is the topology table, and you can see that the destination along with the successor, that which destination is a successor of which node or device. Similarly, the feasible successor will also be available in the path. So you can have the update over here. So this routing table will be get updated using this kind of information that is provided by the neighbor table and the topology table of overall the network, or AS actually. So a feasible successor is a backup route or stored in the topology table. So if, let's suppose, this router, this path actually fails, this interface or this links gets down, so you can have alternate path that will be immediately inserted into this routing table. So that is why it has a rapid convergence. The thing we have talked about is rapid convergence. So this is a rapid convergence. Then it has stored a feasible successor, that if this link or this path gets down due to any reason, due to any load failure or power failure or any breakage of the connection, you will have any other path that is a feasible path. So that is why it provides a rapid convergence of the network. The neighborship table, usually referred to the neighbor table, records information about the routers with whom the neighborship are currently have been formed. The topology table stores the route advertisement about each and every route in the network received from each neighbor. So you can see that it is basically maintaining very much information about your network. So if you are using this IGRP protocol, the major thing is that you can have a good packet delivery, or you will not be facing much packet losses. So that is why this is the most important protocol to discuss, and that is why I am going to discuss this in this lecture series. And the route tables store the routes that are currently used to make the route decisions, and there would be separate copies of each of these tables for each protocol that is actively being supported by this EIGRP, whether it is IP, IPX, or any AppleTalk, or you can have many more kind of these protocols as well. So these tables are the important thing that you should be learning about, that how these tables are updated and how you can indulge your feasible successor. If you want to take the control, you can also take the control and provide the router to give you the your desired path actually. And the router series that it provides, this supports this EIGRP, and IGRP is basically the Cisco routers 2500 series. So you can also keep in mind that, you should also keep in mind that the router series that uses these kind of protocols are basically Cisco 2500 series. This is the series of the Cisco routing protocols, assisting Cisco routers and this provides you support of IGRP and EIGRP, etc. The basic terminology that is basically involved in these protocols is feasible distance, reported advertised distance, etc. So this is nothing but the same thing that we have already discussed, that feasible distance is the best metric along with all the paths to remotely access the network or remotely connecting to the network. Includes all the other metrics, for example the bandwidth, the energy required, or you can say the hop count or delay or packet delivery or channel link or capacity or user support. You can have any metric by your own and it will support that metric, so you do not have to worry about that. And let's talk about this EIGRP tables, because I've told you that how these things actually working. So the neighbor table and the topology table are held in the RAM actually. So this kind of protocols basically uses the help of the RAM, and it stores the topology and the information of the neighbor tables into the RAM, and these are maintained through the use of the packet of hello. So you must have to send a hello packet towards your destination, so that you will be able to find the response, and after that response you will be update your packets and update your neighbor tables and then your topology table, and in the last you will corresponding to this neighbor table and the topology table you will be forming this routing table, and this routing table will be a good routing table as compared to the previous protocols. So successor routes are those routes which are used by this IGRP to forward your packet or traffic to a destination, and this successor router may be backed up by a feasible successor route, and you can see that you can have both of these paths stalled or stored within your routing table. So this information is stored in your topology table. You've already seen in the previous slide as well, and based on this this topology table, your routing table gets updated every 90 seconds of time. So how this protocol chooses the routes actually. So EIGRP uses the composite metric, and what is composite metric? It is a combination of any metric that you want to, but the default is a bandwidth and delay. You can see that the bandwidth and the delay is set it as a default, and you can also insert more metrics as well in this kind of protocols, and you can also include load balance across 6 unequal cost path to remotely access the network, and the value is set it by default of 4. So there is a quick assignment for you, and I hope that you will be able to do it by yourself, and if not we will discuss that in the class also, so don't worry about. If you I will highly appreciate if you find some answer for me. Even the answer is wrong, I will just support you and appreciate your effort if you tried to find the answer, and you have to prove that you have tried your best to find the answer. And the thing that I want you to do it by yourself is basically you have to check that assuming all the given parameters that is defined over here, and the default parameters that you know that the RIP uses 15 hops and EIGRP uses 100 hops by default, and the values of uneven load is 4 by default. You have to tell me that which route RIP version 1 and version 2 will take, and which route this EIGRP actually takes, starting from this path to this path. You have to tell me that which path both of these protocols will take. And this is the last slide actually, where you have to verify the EIGRP operation. So the first thing that this protocol does, it actually displays the neighbors discovered by the IP enhanced EIG protocol, and after that it provides you the display. It displays you the this topology table. After that, the current EIGRP entries in the routing table are displayed, After that, there is a display of the parameters and current state of the active routing protocol process. And in the last, you will have to display all the information about the number of enhanced packets, enhanced IGRP packets that are sent and received. So this is the major thing that you check at the end, at how you can find the traffic. Actually, this is regarding to traffic, this is regarding protocol, this is regarding route, this is regarding topology, and this is regarding neighbors. So these are the 5 things that this IGRP EIGRP basically performs one by one. So the first thing is this provides the neighbor information, then the topology information, then the route information, then the protocol information, and the last it provides you the traffic information. So you can see that you can have a very much good overview of overall network as compared to the other protocol. And let's talk about the comparison as compared to the complexity level. So you will have to answer me that as comparison to with this RAB protocol, is this protocol is more complex or more easy as compared to this RAB protocol? So let's talk about this in the class as well, and it is very much easy. You will get the answer if you have watched this video completely. You will be able to find the answer for me as well, for yourself. So that's all for the first part of the lecture. I'll see you in the second part, and if you have any question, please write it down with yourself and do bring them in the class, because you know that the more you ask, the more you learn. That's all for the first part. I'll see you in the second part. Thank you. Allah Hafiz.